So in this video, we're going to verify the sine of 3 pi over 2 plus x plus the sine of pi over 2 minus x. And we are going to find the answer using the two different ways. And the first way is to use the fundamental trigonometric identity, which is the sum and difference identity. And another way to solve it is to apply the transformations of the angles on the unit circle. And the second one, it is more advanced, so I'm going to do it in the next video. And in this video, we're going to apply the sum and difference identity to solve the sine of 3 pi over 2 plus x plus sine of pi over 2 minus x. After watching this video, you have to check out the next video where I'm going to solve the same problem in a different way using the angle transformations on the unit circle to relate it with the sum and difference identity and compare which one is better. Just like I mentioned, we are going to use the sum and difference identities of the trigonometry. And if you're not familiar with this concept before I start, you need to go back to my previous videos about what is the sum and difference fundamental identities in trigonometry. And there we said the sum literally means we add two angle measurements to figure out the angle rotations trig values on the unit circle, which we can express easily. Difference means we subtract two angle measurements to figure out that the angles trig values, just like I explained in our previous videos. So the first thing that we're going to talk about is kind of review what is the sum identities. And as we can see, we are dealing with the sine, sum, and difference identities. So let's start off by thinking, what is the sum identity for the sine? If I briefly explain what is the purpose of sum identities for the trigonometric identities, because we might have the angle rotation such as 15 degrees, 75 degrees, or 105 degrees, and on the unit circle that we explained in our previous videos. And we cannot express its sine, cosine, or tangent trig values because they are not the terms or the angle measurements we can explain or we can express with the three special angles: pi over 6 radian, 30 degrees, pi over 4 radian, 45 degrees, and pi over 3 radian, which is 60 degrees. However, by manipulating these three special angles, pi over 6 radian, pi over 4 radian, pi over 3 radian, we can either add them or subtract two of those angle rotations to form that angle measurements. And when we think about its identity, we express two special angles in terms of alpha and beta. And alpha and beta should be two of those angle rotations. So this is basically what the sum identity is. If we add those two special angles, alpha and beta, and there's a possibility where the alpha and beta can be exactly the same value, when we add those two alpha and beta to form an angle measurements that we can express using special angles, and we want to find the sine of that angle. And we have to remember that the common mistake is people might think that we can distribute the sine to alpha and beta. So we can distribute sine to alpha and beta and create sine of alpha plus sine of beta. But you have to remember that the reason why we're applying this is because we cannot apply the simple operations like we did while we're dealing with the real numbers. This is different. This is the part of the trigonometry. That's why we cannot distribute using our operations, and that's why we have something called an identities. And again, identities is something that always works unlike equation, just like I explained in our previous videos. So sine of alpha plus beta, the formula is sine of the first angle alpha, cosine of the second angle beta. And when the two angles are being added, which is sum identities for sine, then the two expressions will also be added. So plus cosine of alpha times the sine of the second angle beta. And this is what the sum identities for sine is.
And in a previous videos, I also explained how to memorize the sum, its sum and difference identities for trig values, sine, cosine, and tangent. But the way we talked about to memorize is kind of childish at first time, but it will help us a lot as we get to solve the question. And the reason why we have to remember it is because if we don't remember the sum and difference identities, which are the most important and often used identities, we won't be able to even approach the trigonometric question. And the way we talked about to memorize is that the order of the angles is always alpha and beta. Alpha, beta, alpha, beta. And the way to memorize the sine is we memorize how it is pronounced. So for sine, some identities, we call it as sin, cosine, with the order of angle alpha, beta, and this is how we memorized it. So sine, we call it as sin, just like how the writing is pronounced. Cosine sounds like co, so we have cosine. And when it is a sum identity for sine, then the midterm will be additions. And we have to remember that this is the sum identity for sine. And for the sine's difference identities, which I'm going to explain right now, where we subtract the two angle measurements, two special angles, such as alpha minus beta, to form an angle measurements on the unit circle to find its sine value, then we don't have to memorize it, because only thing that is different with the sum identity is that the midterm in the sum identity is plus, but the sine of alpha minus beta, which is a difference identity for sine, the midterm will be minus, like this. So sine of alpha minus beta, again, we cannot distribute the sine to both angle measurements, because in trigonometry, while we're dealing with the identities, the simple or the basic operations that we apply to solve a normal question won't work. That's why we have the identities. Sine of alpha minus beta, which is a difference identity, have the same value of sine, except when it is sine of cosine beta, you should be minus in the midterm. Cosine alpha times the sine of beta. And again, they have the same order of angle alpha beta, just like I explained, and it will be sin cosine, just like we learned how to remember it, which is sine alpha times cosine beta minus cosine alpha times sine beta. This is what the difference identity for sine is. So we just quick reviewed what was the sum and difference identities for the trigonometry for sine. And again, before we start anything, we have to remember these identities, otherwise we won't be even able to approach the trigonometric question. So I'm going to erase the thing that we color-coded right now, because we should not be confused with that mark that we did right now with that color. And I'm just gonna leave the formula for sine and difference identity for sine like this. So sum and difference identities, we have to remember to solve the question. What the question we're dealing with right now is what is the sine of 3 pi over 2 plus x plus the sine of pi over 2 minus x. And the reason why we can apply the sum and difference identity is because there's two sines, and just think of the 3 pi over 2 radian as the alpha that we talked about right here. Just think about it as the alpha, and think of the x as the beta. And also here, think of the pi over 2 radian as the alpha in this difference identity for sine, and think of the minus x, the x as the beta. But we have to know that this alpha and this alpha are different values. So let's start by applying the identities for sine. So let's think about this separately. Let's think of the sine of 3 pi over 2 plus x first. After defining it, we will add them together. So we're going to define what is the sine of 3 pi over 2 radian plus x. And according to the formula, what happening is we can apply the sum identity for sine, and again it will be sine of the first angle, which is 3 pi over 2 radian, according to the formula of sine identities, times the cosine of the second angle, which is x in this case. And since it is plus in the midterm, which is the sum identity, then it will have its plus sign, plus the cosine of the first angle, which is 3 pi over 2 radian, cosine of 3 pi over 2 radian, and lastly we will have multiply by sine of the second angle, which is positive x. So this is the extended version for sine of 3 pi over 2 plus x, the sine sum identities. And all you have to do right now is to solve it. And using the knowledge that we used a lot in a lot of videos, what is the sine of 3 pi over 2 radians? Well, if you don't understand this, you need to go back to my previous videos about what are the angle rotations on the unit circle. But if you know what the 3 pi over 2 radian is, which is 270 degrees, the sine of 270 degrees, which is sine of 3 pi over 2 radian, is -1, times the cosine x. We'll just write it as the cosine x, because we don't know what angle the x is, and we don't know which coordinate it lies on. So x plus cosine of 3 pi over 2 radian, and just like I said, with the same angle rotations to 3 pi over 2 radian, then the cosine of the value will be 0. We'll have 0 times the sine of x. And again, we just write it as the sine of x because we don't know what angle x exactly is. And again, anything multiplied by 0 turns into 0. And we have -1 times cosine x, which we simply know as the negative cosine of x. So we just defined the sine of 3 pi over 2 plus x, the sine of 3 pi over 2 plus x, using the sum identity for sine. All you have to do is solve for sine of pi over 2 minus x to add the two terms to get our final answer. So the second term that we're going to deal with is obviously the sine of pi over 2 minus x, sine of pi over 2 minus x. And obviously we are subtracting two angle measurements, pi over 2 and x. We're subtracting two values, two angles, to define or to find the sine value of the angle measurements. Then we can always figure out that we have to use the difference formula. And if you apply the difference formula, that will be sine of the first angle. What is the first angle? Pi over 2 radian. Times the cosine of the second angle, which is x, just like the sum identities, but the difference between sum and difference identity is that for sum it has divisions, but for difference we have subtractions. Cosine of the first angle, pi over 2 radian, times the sine of the second angle, which is x. And again, to solve for it, all you have to do is simplify these values. And what is sine of pi over 2 radian? Well, if you go back to my previous videos about what are the angles on the unit circle, we will eventually know that pi over 2 radian is 90 degrees. And the sine of pi over 2 radian is +1. Times the cosine of x. What is cosine of x? We don't know which angle the x is, and we don't know which coordinate it lies on. So we'll just write it as the positive x, cosine of x. We have minus because the sine of pi over 2 minus x is a difference identity. Cosine of pi over 2 radian. And again, they have the same angle rotation as pi over 2 radian, which is 90 degrees. What is a cosine value when it is pi over 2 radian? Well, that is equal to 0. Times we have sine of the angle rotation, which is the x. And all you have to do is simplify it. And again, anything multiplied by 0 cancels out 0. All we have is 1 times the cosine x, which is just positive cosine of x. We have to go back to our equation to solve it, but we figure out that the sine of 3 pi root 2x is negative cosine x, sine of pi root 2 minus x, sine of pi root 2 minus x is positive cosine x. What is our equation again? We're trying to define what is the sine of 3 pi over 2 plus x plus the sine of pi root 2 minus x. But we couldn't add those terms because we cannot apply the this distribute property from sine to each angle rotations just like I'm doing right now. Because in trigonometry, while we're solving or verifying, we cannot apply in this case, where it is sine of 3 pi root 2 plus x plus the sine of pi root 2 minus x, we cannot apply the basic operations. So that's why we need another way to solve it, which is the identity. And using the sum and difference identities for sine of 3 pi root 2 plus x, we define it as negative cosine x. So that is negative cosine of x. And what is the sine of pi root 2 minus x? We define the sine of pi root 2 minus x as a positive cosine x. And again, we have our answer, negative cosine x plus cosine x. So what is negative cosine x plus cosine x? Well, they have the same term as cosine x, but one of them is plus, one of them is minus. So they will all cancel out as 0. So our ultimate answer for this question is 0. And we solved this question using the sum and difference identities for the sine of the special angle pi over 6 pi over 4 and pi over 3 radians. And it took a while for us to solve this. And in the next video, you have to check it out, which is solve the exactly same question, sine of 3 pi root 2 plus x plus the sine of pi root 2 minus x, but using more advanced technique, which we talked about also in a previous video, which is the transformations of angular rotations on the unit circle.